In this video we are going to look at the problems. Actually they are problems which help you feel everything which is needed to solve inequalities. Alright, so as was mentioned before, we are talking about three possible representations of our solutions of our intervals. The easiest and the most natural to our eye is, I think, graph representation, which directly shows you on the number line what is what. As you maybe remember, the intervals can be of different types, and of the most interest to us is the boundary points, the beginning point and the finishing point of the segment. They can be included in our segment or in our interval, in other words, or they can be excluded. If they are included, it is called closed, and this we depict with square brackets. And when we don't include, we don't blacken, or in this case redden, the points. We just draw circles, and we in interval notation we use usual brackets, round brackets. And another possible way to represent the same thing is just to write inequalities, direct inequalities. It is like set builder notation or inequality description, like in this piece of information. So this is another way. So we have three alternative ways to show our intervals and to work with our intervals: the graphic, then interval notation, and inequalities or set builder notation. Let us do what is needed to be done together. This was from my... Alright, so in every problem you will be given one of the possible representations, and you will be asked to write the other two. Let's have a look here. We have open interval here, which I know from this circle, closed here, and it stretches from -4 to +4. In this case, I write x is lower than +4 and equal to. Here the inequality is strict, as we say. We don't include equality, and it's -4. So x is greater than -4, and x is at the same time, x is lower than or equal to +4. As for interval notation, that's pretty easy to write. We don't include the first -4, which we denote by this round bracket, usual bracket, and this one we include, which we show by the square bracket. In this case, we have an interval from -3 closed to +5 closed. Points are included. Let me first draw. When you draw Okay, I'll draw it like in your case without colors. I must blacken both points, -3 and now +5. And I think my choice is to draw this. Another alternative is just to do like this. Or another alternative is to do like this, to put a lot of slashes here. But my choice, I will be doing like I showed in the first instance, so I won't be using that. But you, it's up to you. And now I have to write set builder notation. It means that my x is, let me begin with the lower side, greater than or equal to -3, less than or equal to +5. This is it, we are good to go. In this case, the second problem, in this case we are given a graphic representation of our problem. We see that point 3 is included, so we have a closed interval. On the other hand, it stretches infinitely. I didn't put it up to the arrow, but it's obvious that it goes. Otherwise, I would either draw a circle or blacken it. So in this case, I just write that x is greater than +3 or equal to +3. I can also write this in another way, like here all the time. So +3 is less than or equal to x. So x is greater than +3 in this. But when there is only one inequality, not double, it's more natural to write this like this. X is greater than or equal to +3. In the last box here, I write just 3 with a square bracket. And here, remember, plus infinity, you never include it. It's always open. Here it is. It was done. The points are already. This one is circled because it is not included. This one is blackened because it is included. I draw something like this. And now I have to write an interval notation for this. So 1 is not included, -1, sorry, is not included. And then +3 is included. And here I have very similar thing. 3 positive is included, but this time it's +1, which is not included. So it will be like this, and like this, and like this. And the inequality or builder set notation would be x is lower than or equal to +3 and greater than, without equal to, +1. Here in this case, open interval starting from -8 going to +3. All right. Let me write the builder set notation first. X is greater than, and without equal to because it's open, -8, and less than, again not without equality, +3. Here, when I write interval notation, I just draw round parentheses, usual parentheses, and appropriate numbers like -8, and the other end it's +3. Now x is greater than 5. without equality, it means that we don't include 5, and it's like that. Everything to the right from this point. And here, if we don't include 5, this end is round. And then it goes, stretches to plus infinity, positive infinity. Here we have a more complicated interval with 2 parts. The first one stretches from -8 to -5, -8 half closed, -8 closed, -5 open. All right, -8 here, -5 here. That's our first. And it is unified with, it goes together with another interval which stretches from +6 to +8, open both. +6, +8, here we are. And here we write double inequality. And we can write in this style using the square thing, which means this, or just write the word or. So I think I'll prefer to write the word or, and this will give me the first set, the first part of the set. X is less than -5. X is greater than or equal to -8, or X is less than +8 and greater than +6. That is it. And in the next example, we have again an interval which stretches from -infinity to something. This something is 1, which is included. This means this gives us X is lower, less than or equal to 1, and nothing on the other end. But in interval notation, we include infinity sign, and this point is included. Here we have either X is less than -6, and it is not included. It means this interval. And oh, I'm so sorry. Dangerous times, especially for coffee. And here I have open 5, and closed 7. This is my second part of my set. And now I'm good to go to write down the interval notation. The interval notation gives me from -infinity to 6, -6, open, and this is unified with from 5 open to 8, why 8? It's 7. Now it's easier for me to change it here, but the original problem was not like that. All right, I'll put 8 here. What I did is, I don't know. I thought it was 8, but it was 7 actually. Okay, we've cheated a little. I corrected the initial problem. It's not good, but it's all right. We're training. So now we're given interval notation. It means that it stretches from -infinity to -5 included. This end is closed. In which case I blacken it properly. And as for build the set notation, it's X less than or equal to -5. In this case, I have again two parts of my set. Let me start with builder set notation, set builder notation. 7 is not included, so x is just greater than -7. X is less than or equal to -1, or x is greater than 4, and that's it. It stretches up to infinity. As for interval notations, I have to use this and sign. The first one being, the first part is from -7 open to -1 closed, unified together, and from 4 open to plus infinity. That's it. In this case, we're given set builder notation. And it's greater than 5, so 5 is not included, and everything to the right. All right, here we just have 5 is not included, so it's round, open, and that's plus infinity. It is never included, it's always open. We're going to do the last problem. So on this first sheet, and then you can train yourself. Well, the last one is we're given from -5 to +4 open. It means that x is less than +4 and greater than -5. And here the last interval notation gives us that's -5, and here +4, and they are both open. As you see, it's pretty obvious how to do that. If you forget something, you just turn to the first page. You can turn to the videos in that, to previous videos. And those are all in those pictures. You can find any information you might have forgotten. But I don't think so. You'll be fine. It just needs getting used to, that's all. But all notations are equally important. Maybe the most frequent which is used is interval notation. But we have to understand set builder notation as well. And as for graph notation, graphic representation, we just it's best for us. And by the way, when we find difficult, when we solve difficult systems of inequalities, graph representation becomes very important. So I would say that all three of them are important. It's not that we can study and know two of them and forget about the third. No, there are three equal things. They are important. So good luck with training. There are many other problems for you to train, and actually you can even derive your own problems and train also. Good luck and see you later.